Good afternoon, students. Today we will discuss the topic potentiometer. So this is also similar to that of the meter, right? So what is potentiometer? Potentiometer is a device which is used to measure the potential difference between any 2 points in an electrical circuit, and also it is used to measure the EMF of a cell and also the internal resistance of the cell, right? So what is potentiometer? It is a device used to measure it is used to measure the potential difference between 2 points in an electrical circuit, right? So it is a device which is used to measure the potential difference between any 2 points in an electrical circuit. So if we consider any one circuit, so electrical circuit means it consists of both the resistance and EMF, right? So for example, this is one electrical circuit. So if we name it, the nodes A, B, C, D is a one closed loop, right? So if you want to find the potential difference between any 2 points in a closed electric circuit, right? So here I want to find the potential difference between the point A and point B. That is the potential difference between point A and B. Then here we are going to use the device. So that is called the potentiometer. That is the potential difference between any 2 points. So either in between A and B, or in between A and D, or in between A and C. That means point A and point C. If we want to find the potential difference between point A and point C, so we are going to use the potentiometer, right? So that is to find the potential difference between any 2 points in an electrical circuit, right? So it is also used to measure EMF or internal resistance of a cell. So potentiometer is also used to measure the EMF. So here if we have any one cell which is connected in an electric circuit, or individually we have one cell, right? So this cell having both the EMF and also the internal resistance. So we don't know the value of the EMF of the cell, or we don't know the internal resistance of a cell. So to find the EMF of a cell or internal resistance of a cell, so we are going to use the device. So that device we call as the potentiometer. So from the help of the potentiometer we can find the EMF of a cell or internal resistance of a cell, right? So these are the two applications of the potentiometer, right? So one is used to measure the potential difference between any 2 points in an electric circuit, and also we can find the EMF of a cell or the internal resistance of a cell, right? So one main advantage of the potentiometer is it gives accurate measurement. It gives accurate measurement when we measure the potential difference or EMF of a cell, right? So it gives accurate measurement when we measure the potential difference between any 2 points or EMF of any cell. So that is because the potentiometer will not draw any current from the cell. So now ಯಾವ ಸೆಲ್ದು EMF ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡಿರ್ತೀವಿ, ಅಥವಾ ಯಾವುದಾದ್ರೂ ಬಿಟ್ವೀನ್ 2 ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ನಾವು ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ, ಸೊ ದ ಪೊಟೆನ್ಶಿಯೋಮೀಟರ್ ವಿಲ್ ನಾಟ್ ಡ್ರಾ ಎನಿ ಕರೆಂಟ್ ಫ್ರಮ್ ದ EMF. ಸೊ ಈ ಸೆಲ್ ಇಂದ ಯಾವುದೇ ತರಹದ ಕರೆಂಟ್ ನ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. ಹೆನ್ಸ್ ದ ಪೊಟೆನ್ಶಿಯೋಮೀಟರ್ ಗಿವ್ಸ್ ವಾಟ್ ದ ಅಕ್ಯುರೇಟ್ ಮೆಜರ್ಮೆಂಟ್, ರೈಟ್? The reason because it gives accurate measurement, because potentiometer do not draw any current from the cell, in which we are going to find the potential difference or EMF. Now ಯಾವ cell ಅಲ್ಲಿ potential difference ಅಥವಾ EMF or internal resistance ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡಿರ್ತೀವೋ, ಸೊ ಅಂತ ಸೆಲ್ ಇಂದ ಯಾವುದೇ ತರಹದ ಕರೆಂಟ್ ನ ಏನು ಮಾಡೋದಿಲ್ಲ, ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಡ್ರಾ ಎನಿ ಕರೆಂಟ್ from that cell, right? So that one is the main advantage. Hence it gives what, the accurate measurement to in finding the values of EMF or the potential difference, right? So this is about the potentiometer. So right, what is potentiometer means? It is a device which is used to measure the potential difference between any two points in an electrical circuit. And if they ask for the applications of potentiometer, means it is used to measure the EMF or internal resistance of the cell. So it gives accurate measurement because it will not draw any current from the cell. So in which cell we are going to find the potential difference or EMF or internal resistance. So from that cell the potentiometer will not draw any current, right? So now the first application, to compare the EMF of two cells, right? So ಇದೆಲ್ಲದೂ ಕೂಡ ನಿಮಗೆ ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ just theoretical purpose ಅಲ್ಲಿ ಇಲ್ಲಿ explanation ಇರುತ್ತೆ, right? So to compare EMF of two cells, that means if we know the value of one EMF, we can find the value of the another EMF in with the known EMF. So unknown EMF ನಾವು find out ಮಾಡಿದೀವಿ ಅಂದ್ರೆ with the known EMF, right? So the circuit connection is like this. So having the cell, the first one is cell E1 and the second cell is E2, right? So here also same, a uniform long resistance wire is mounted on the wooden bridge, right? So of length L, right? Naming these points of AB. So the length of AB is L, and AB is a uniform thin, long, uniform resistance wire. So the resistance at each and every point remains the same, right? So now this resistance wire is connected to the external source. We call that one as battery, along with one resistance and one plug key. So this we call as plug key. Is taken as variable resistance. So resistance given arrow that indicates what, the variable resistance. So external source, battery, right? So these two cells is connected to the circuit, right? So this is the external circuit. So cells E1 or E2 is connected to this external circuit by using the two-way plug key, right? So two-way plug key means it is used to connect both the cell E1 and E2. So that type of key we call as two-way plug key. So naming the points 1, 2 and 3. So from the point 3 we are connected one end of the galvanometer to the point 3 and another end of the galvanometer to the slider. So ನಮಗೆ galvanometer ಅಲ್ಲಿ two ends ಇರುತ್ತೆ. One end is connected to the terminal 3, right? So another end of the galvanometer is connected to the slider, right? So now in the first case, by using the two-way plug key, cell E1 is connected to the external circuit. So this is the external circuit. So AB is a uniform resistance wire of length L. So meter bridge ಯಾವ ತರ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ AB is an uniform wire. That means uniform means its area of cross section remains same throughout the length AB, right? So ಅದರದ್ದು length ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ total length from A to B is L, right? So now the cell E1 is connected to the external circuit by the two-way plug key. That means connecting the point 1 and 3. So E2 cell will not work under this case. So E1 connect ಮಾಡಿದಾಗ external circuit ಅಲ್ಲಿ E2 is not working. So the current is flowing from the E1, right? So the current is flowing from the E1. So cell E1 in the current ಏನಾಗ್ತಿದೆ flow ಆಗ್ತಿದೆ to the external circuit, right? So now by using the slider, the condition is to do is the current through the galvanometer is to be 0, right? So that is the balancing condition. So even na connect ಮಾಡಿದಾಗ external circuit ಅಲ್ಲಿ we are going to measure the balancing length. So slider we are moving from point A. So point A ಇಂದ move ಮಾಡ್ತಾ ಹೋದಾಗ particular point at a particular length the galvanometer shows 0 deflection. So that means the needle in the galvanometer shows the 0 position, right? So that means the current which is flowing in the galvanometer is 0, right? So when cell E1 is connected to the circuit. So first case allen ಮಾಡ್ತಿದ್ವಿ only the cell E1 is connected to the circuit, right? So next we are going to check the balancing condition. That means the current which is flowing in the galvanometer we are making that one as 0, right? So that means directly we can write cell E1 is connected to the circuit and noted the balancing length. So cell E1 na connect ಮಾಡ್ತಿದೀವಿ. Next ಏನ್ ಮಾಡ್ತಾ ಇದ್ವಿ by moving the slider on the resistance wire. So ಈ wire AB is a resistance wire. So ಈ wire ಮೇಲೆ ಒಂದು slider ನ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ move ಮಾಡ್ತಾ ಇದೀವಿ for a particular length. So I taken that one as L1. Either it may be 10 cm, 20 cm or 30 cm. So ಅದು ಯಾವುದೇ ಲೆಂತ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಯಾವುದೋ ಒಂದು particular length ಅಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಷನ್ ಇಂದ galvanometer ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. ಸೊ ಅಂತ ಲೆಂತ್ ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಲೆಂತ್, right? So balancing length is L1, right? So balancing length is what means at the length the current in the galvanometer is 0. So ಇಲ್ಲಿ galvanometer ಅಲ್ಲಿ current 0 ಆದಾಗ ನಮಗೆ ಒಂದು ಲೆಂತ್ ಬರುತ್ತೆ. ಸೊ ಆ ಲೆಂತ್ ನ ಏನಂತ ಕರೀತೀವಿ ನಾವು ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಲೆಂತ್, right? So now from this we can write E1 is equals to pi into L1, right? So where pi is a constant, so that constant we call as potential gradient, right? Where pi is the potential gradient. So potential gradient means potential per unit length. So how we define the potential gradient means potential per unit length. So potential per unit length ನಾವು ಏನಂತ ಕರೀತೀವಿ potential gradient. That means any changes with respect to length we call that one as gradient. So here potential is changing with respect to length, hence we call that one as potential gradient, right? So temperature is changing with respect to length means temperature gradient. So here the potential is changing. So length change ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ potential ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ change ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So we define this one potential per unit length, that is E divided by L. So again we get the same here, E by L, that is equals to pi. Potential per unit length, that is constant. So that constant we naming as potential gradient, right? So that one we written in terms of EMF or potential. E is equals to pi into L1. So this is the first case, right? So in the next case, removing the cell E1. So next what we are doing is removing the cell E1 and we are connected to the cell E2, right? So E1 na disconnect ಮಾಡಿಬಿಟ್ಟು E2 is connected with the circuit, right? So E2 is connected to the circuit. cell E2 is connected to the circuit and noted the balancing length. So next time E1 and E2 are the two cells of different EMF. So E1 and E2 ಎರಡು different EMF ಇದಾವೆ. So first ಏನು ಮಾಡಿದ್ವಿ E1 ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ ಈ ಸರ್ಕ್ಯೂಟ್ ಜೊತೆಗೆ. So next case ಅಲ್ಲಿ E1 ರಿಮೂವ್ ಮಾಡಿಬಿಟ್ಟು E2 we are connecting into this circuit. Now the current is flowing from the cell E2. So E1 ಏನಿದೆ ನಮಗೆ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿರೋದ್ರಿಂದ the current which is flowing in the cell across this circuit, right? Again by moving the slider from point A. So ಈ point A ಇಂದ slider ನ ಮೂವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. So at a particular distance again the galvanometer shows zero deflection, right? So this is somewhere here we get. So ಇದು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಬರುತ್ತೆ. So this is in general we are discussing, right? So somewhere here we are getting the balancing length, right? So that the length we taken as L2. Right? So when cell E2 is connected with the circuit, we are getting the balancing length L2. So at this length, the galvanometer shows zero deflection, right? So from this, again we can write E2 is equals to pi L2. Because the wire resistance is uniform, hence we are getting pi as it is same. So first case ಅಲ್ಲಿ ಏನು pi ಬಂದಿರುತ್ತೋ second case ಅಲ್ಲಿ ಕೂಡ same ಇರುತ್ತೆ because resistance at each and every length ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ at a particular point remains constant, right? So calling this one as equation 1, equation 2. Now divide equation 1 by 2. Divide equation 1 by 2, right? So E1 by E2 that is equals to pi L1 by pi L2, right? So pi get cancels, we get E1 by E2 that is equals to L1 by L2. So ಇದರಲ್ಲಿ ನಮಗೆ E1 ಗೊತ್ತಿದ್ರೆ the EMF of the cell E1 we know, so E2 is unknown, so here we getting the balancing length L1 and L2, so easily we can find E2. So this is what comparison of EMF of two cells. So E1 by E2 is equals to L1 by L2. So when L1 and L2 are the balancing length of EMF E1 and EMF E2, right? So here balancing length. So ಇದು ನೀವು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಕ್ಲಿಯರ್ ಐಡಿಯಾ ಸಿಗುತ್ತೆ, right? So this is about the comparison of EMF of two cells, right? So on the next application, so the second application to measure internal resistance of a cell, right? To measure the internal resistance of a cell, that means we are going to measure small r, right? So here we are going to find the internal resistance of the cell E, right? So circuit connection as shown here in the figure. So here we have the two keys, two plug keys, not two-way plug key. Here direct single-way plug key, right? So one plug key we call that one as K1 and another plug key we call that one as K2. That is key 1 and key 2, right? So now K2 open, right? keeping key K2 open, right? So key 1 is connected. That means current is flowing in the circuit. So K1 connect ಮಾಡಿದಾಗ current is flowing in the circuit along with this EMF. So ಇಲ್ಲಿ ಮಾತ್ರ ಈ resistance, the current which is flowing across this resistance is zero. So ಈ resistance ಅಲ್ಲಿ ಏನಾಗೋದಿಲ್ಲ ನಮಗೆ current flow ಆಗೋದಿಲ್ಲ, right? So now again by using the slider we are going to find the balancing length of the EMF of the cell E. So each cell to balancing length find ಮಾಡ್ತಾ ಇದೀವಿ. That means the current is flowing in the circuit across the cell and to the galvanometer. So we are going to make this galvanometer current is zero. That means by sliding the slider we getting the balancing length of the EMF E, right? So that balancing length will taken L1. So K2 keeping open. Open means there is no circuit, complete circuit connection. That means this is open circuit. So ಇಲ್ಲಿ ಯಾವುದೇ closed circuit ಇರಲ್ಲ. So closed circuit ಇರಲ್ಲ ಅಂದ್ರೆ there is no flow of current in the resistance R. There is only the current which is flowing through the cell, right? So for this cell the current in the galvanometer we have made to zero. That is the balancing length L1, right? So from the last comparing of EMF of two cells ಅಲ್ಲಿ ನಾವು ಯಾವ ತರ ಬರ್ತೀವಿ same here. So EMF E that is equals to pi into L1, where pi is the potential difference, where pi is the potential difference per unit length, right? So balancing length we are getting by the cell E. So that's why we have written E is equals to pi L1, where L is the length of the resistance wire AB. So here also the resistance wire is uniform resistance, right? So next, second case, close both the keys K1 and K2, right? So first case only we are closing the key K1, right? So in the second case we are closing both the keys K1 and K2. So ಇಲ್ಲಿ ಒಂದು dot represent ಆಗ್ತಿದೆ ಅಂದ್ರೆ now the circuit is completely closed. So it is a closed circuit, right? So ಎರಡು ಕೂಡ closed ಆಗಿರುತ್ತೆ. So now the current is also flowing through the resistance R, right? So ಇಲ್ಲಿಂದ flow ಆಗ್ತಾ ಇರೋ current, some current is divided across the E and some current is divided across the R. That is from the Kirchhoff current law, right? So current is flowing across the resistance and to the galvanometer, right? So ಇಲ್ಲಿ flow ಆಗ್ತಾ ಇರೋ current ಕೂಡ ಏನಾಗುತ್ತೆ same ಇಲ್ಲಿ flow ಆಗುತ್ತೆ. So again we are going to find the balancing length for the both the resistance and the EMF. So ಇದನ್ನ connect ಆಗಿದೆ. So this is in the parallel combination. So cell is connected with the resistance R. That means small r and capital R both are in parallel, right? So now we are going to find the balancing condition, right? So balancing condition, here we are going to find the potential across the cell, right? So that is V is equals to, so somewhere here we get the balancing length for both the keys are closed, right? So that one we taken the length L2, right? So V is equals to pi into L2, right? So first equation, second equation. Now same, divide equation 1 by 2. So E divided by V, that is equals to pi L1 by pi L2. So we get E by V is equals to L1 by L2, right? So I already mentioned in the last class, so potential will remain same in the parallel combination. So EMF cell ಅಲ್ಲಿ potential ಎಷ್ಟಿರುತ್ತೋ the same potential is across the resistance R. So ಯಾವುದಾದರೂ ಎರಡು resistance ಅಥವಾ ಎರಡು cells parallel ಅಲ್ಲಿ ಇದ್ರೆ the potential ಏನಿರುತ್ತೆ ಯಾವಾಗಲೂ ನಮಗೆ same ಇರುತ್ತೆ, right? So the potential across the resistance, that is equals to the potential across the EMF E, right? So from Ohm's law, we can write V is equals to I into R, right? So This gives what? The potential. So the same potential is across the cell E, right? So from the cell, the current which is flowing I is equals to E divided by R plus R, right? So the current which is flowing across this cell, right? So that current we are taken I is equals to E divided by R plus R, right? So substitute this, we get V is equals to ER divided by R plus R. So substitute I to the voltage V, right? So now substitute V here. So E divided by, instead of V, we are writing ER divided by R plus R. That is equals to L1 by L2. So all E in the numerator and E in the denominator get cancelled. So this R plus R goes to the numerator. R plus R divided by capital R, that is equals to L1 by L2. So our aim is to measure the internal resistance. That means we are going to measure the small r. So from this relation we are going to measure the small r, right? So we get this one plus small r divided by capital R, that is equals to L1 by L2, right? So now, so continue this one. Shifting 1 to the RHS, we get in R by R, that is equals to L1 by L2 minus 1. So we need only the internal resistance R. So R is equals to R into L1 by L2 minus 1. So by this method, we are finding the internal resistance of the cell. Right? So these are the two applications of the potentiometer. One is to compare the EMF of two cells, and another one is to find the internal resistance of the cell. So this is the standard formula, right? So ತುಂಬಾ ಸಲ ನೀಟ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿದ್ದಾರೆ. Just substituting the given the external resistance. So external resistance is the resistance which is connected. So E resistance ಕೊಟ್ಟಿರ್ತಾರೆ. Again they given the balancing length L1 and L2. Directly if we substitute L1 and L2 and R, we get the internal resistance of the cell, right? So here we need to remember is first, in the first case K2 is kept open and find the balancing length for EMF E. So ಈ cell balancing length na find out ಮಾಡ್ತಾ ಇದೀವಿ in the first case. So we get the equation E is equals to pi L1, where L1 is the balancing length for the cell E, right? So in the next case, closing both the keys. So first case ಅಲ್ಲಿ key 1 close ಇರುತ್ತೆ. So second case ಅಲ್ಲಿ key K2 ಕೂಡ close ಮಾಡ್ತೀವಿ, right? So now the current is flowing across the cell and also the resistance, right? So the potential in parallel combination remains same. So potential across the resistance R is same as the potential across the EMF E. So ಈ cell ಅಲ್ಲಿ ಎಷ್ಟು potential ಇರುತ್ತೋ the same potential is across the resistance R. So from that we can write V is equals to pi L2. So again divide by equation 1 and 2, we get E by V is equals to pi L1 by pi L2, and from the Ohm's law we can write V is equals to, or we directly write this one, V is equals to ER divided by R plus R. So substituting here and simplifying, we get internal resistance R, that is equals to external resistance which we connected across the cell, and into L1 by L2 minus 1, where L1 and L2 are the balancing length of the cell and the parallel combination, right? So this is about the potentiometer and applications of the potentiometer, right? So by this we completed the chapter current electricity, right? So now we will solve few problems on all these concepts. So in chapter ಅಲ್ಲಿ ನಮಗೆ ಕಂಪಲ್ಸರಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ ಪ್ಲಸ್ on 5 marks ಗೆ theory ಇರುತ್ತೆ, right? So we need to prepare on both problem and 5 marks theory. So potentiometer is also works under the principle of Wheatstone bridge, that is balancing condition, right? So take the first problem. 100 mg mass of Necron metal is drawn into a wire of area of cross section 0.05 millimeter square. Calculate resistance of this wire. Resistance of this wire given density of Necron 8.4 into 10 to the power of 3 kg per meter cube, and resistivity of the material, and the resistivity of the material 1.2 into 10 to the power of minus 6 ohm meter. Right? So this is the question. So this question is also asked in the examination. Right? So first we need to write the given. So the given mass of the Necron. So that is m is equals to 100 mg. So SI unit of mass is kg. So we need to convert from grams to kg. So initially the given milligram, 100 into 10 to the power of minus 3 gram. Now we need to convert from gram to kg, right? So 100 into 10 to the power of minus 3 into 10 to the power of minus 3 kg. So 1 gram is equals to 10 to the power of minus 3 kg, right? So we can write this m is equals to 100 into 10 to the power of minus 6 kg, or we write 10 to the power of minus 4 kg. So here 2 zeros plus 2 minus 6, we get minus 4. Next, Necron metal is drawn into the wire of area of cross section 0.05 millimeter square. So that means the given A. So A is 0.05 millimeter square. So again, SI unit of area is meter square. So we need to convert from millimeter square to meter square. That is 0.05 into 10 to the power of minus 3 whole square meter square, right? So millimeter square, we can write millimeter into millimeter. So 1 millimeter is 10 to the power of minus 3 meter. Again another millimeter, 10 to the power of minus 3. So we can write 10 to the power of minus 3 whole square meter square, right? So this we write 0.05 into 10 to the power of minus 6 meter square, right? Next, calculate the resistance of the wire given density of the Necron, right? So density, the given density, that is equals to 8.4 into 10 to the power of 3 kg per meter. So SI unit of density is kg per meter cube. So no necessity to change this one. Next, and the given the resistivity of the material. So resistivity is denoted by rho. So density we also denoted by rho. So ಎರಡು confuse ಆಗುತ್ತೆ ಅನ್ನೋದಕ್ಕೋಸ್ಕರ directly we write that one as density itself, right? So resistivity rho, that is equals to 1.2 into 10 to the power of minus 6 ohm meter, right? So we need to find the resistance R. So we know the formula for the resistance R. R is equals to rho L divided by A, right? So here rho is the resistivity. So in the given data we don't have any length, but we have the area, right? So they given the mass and also we have the area. So by using the mass data we can find the length in terms of density, right? So we know density is equals to mass by volume, right? So mass m, volume, that is area into length, right? So density is equals to mass by area into length. So we need L. So L is equals to m divided by area into density. Now substitute L here. So rho. So L is m divided by, already one A we have, right? So into area into density, right? So this we can write rho m divided by A square into density. So now we know the value of the resistivity, mass, area and density. So substitute and simplify. So resistivity 1.2 into 10 to the power of minus 6. Mass, that is into 10 to the power of minus 4. Area 0.05 into 10 to the power of minus 6. So it is whole square into density 8.4 into 10 to the power of 3. Right? So this we can write 1.2 divided by 0.05 whole square into 8.4 into 10 to the power of minus 12 into 10 to the power of 3. In the numerator, 10 to the power of minus 6, 10 to the power of minus 4, we can write that one as into 10 to the power of minus 10. Or 0.05, we can write 5 into 10 to the power of minus 2 whole square. Right? So again, we simplify this one. 12 divided by 84 into 0.05 whole square into. So in the numerator, we shifting one decimal. In the denominator also, we shifting one decimal. So we get 12 by 84. So here 10 to the power of minus 10. So plus 12 minus 3. So minus 12 goes to the numerator, it becomes plus 12, plus 3 goes to the numerator, it becomes minus 3, right? So if we simplify this one by using calculator divided by 84 into 0.05 whole square, it gives minus 10 minus 3 minus 13 plus what, 10 to the power of minus 10 to the power of minus 1. So we get the final resistance value R. After simplification, R is equal to 5.71 ohm. So these two simplification is there. If you have any calculator, means directly simplify here only. So you simplify now, right? So the final answer is R is equal to 5.71 ohm. So this kuda once they ask in the examination, right? Second question, a wire having length, a wire having length 2 meter, diameter 2 meter, sorry, length 2 meter, diameter 1 millimeter, and resistivity resistivity 1.963 into 10 to the power of minus 8 ohm meter is connected in series with a battery of EMF 3 volt and and internal resistance 1 ohm. Calculate the resistance of the wire. Calculate the resistance of wire and current in the circuit. And current in the circuit. Right. So here first we know what they are given. So a wire of length 2 meter. So that means they given the length of the wire, that is 2 meter, and also the given diameter of the wire, that is 1 millimeter. So 10 to the power of minus 3 meter, right? And also they given the resistivity rho, that is equals to 1.963 into 10 to the power of minus 8 ohm meter. Is connected in series with a battery of EMF 3 volt, right? So that means the given E value 3 volt, E or V, right? So if the cell having no internal resistance, so that directly becomes E is equals to V, right? So here the given internal resistance, that is small r, and the value is 1 ohm, right? So to find, so here we need to find the resistance which is connected in series. So resistance of the wire and also the current in the circuit, right? So first we need to find the resistance, the given length, diameter and resistivity, right? So from the formula R is equals to rho L by A. But they didn't give any area. So area of cross section we need to find A is equals to pi R square. So circular wire circle alli irutte. Cylindrical shape means area of cross section is always in circle. Hence we are going to find area of the circle. A is equals to pi R square. But the given diameter. So radius is equals to d by 2, that is 10 to the power of minus 3 by 2. 3.14 into 0.5 into 10 to the power of minus 3 whole square, right? So this is what area of cross section. So rho L A. So substitute rho is 1.963 into 10 to the power of minus 8 into length is 2 meter divided by area is 3.14 into 0.5 into 10 to the power of minus 3 whole square by R square. So if we simplify, we get the resistance R value 0.05 ohm. So calculate once try ಮಾಡಿ. So ಎಷ್ಟು answer ಬರುತ್ತೋ ಅಷ್ಟು, right? So after simplification we get the value of 0.05 ohm. Now this resistance is connected in series with the cell E comma R. So here we find R is equals to 0.05 ohm. So from this we are going to find the current I. So they given E and also R. So directly we know the formula, that is I is equals to ER divided by R plus R. E divided by R plus R. So E we have 3 volt, 3 divided by external resistance is 0.05 plus internal resistance is 1, 3 divided by 1.05. I. So I is equals to 3 divided by 1.05. So approximately we get 2.87 amperes. So remaining problems we will continue in our next class. Thank you.